Hello, my dear friends, welcome back. Let's continue with the next topic. For that, the concept video has already been given to you, so I believe that you have prepared. So now we're almost at the end of sets. There are some properties, laws which I've just given just as a reminder, as a revision. It's already been discussed in the concept video, the complement laws, De Morgan's law, which is very important, law of double complementation, law of empty sets, and universal set. So in this exercise we are going to be learning about complement of sets, and a slight knowledge we will be learning about Venn diagrams also. So I believe that you have gone through the videos, concept videos. I will also be providing you in the description box below, so kindly go through that also. All right, so let us just begin with the exercise 1.5. all right. So as the question says, let U, that's the universal set, that's the mother set, no? 1 2 3 4 5 6 7 8 9, the set A, set B, set C. First job is to find the complement of set A. So what is going to be the complement of set A? I can write for you that is set A actually would be all the elements which are not in the set A, that is universal set minus the elements present in the set A. So let me not write down the set, let me just calculate from here. So 1 2 3 4 are present in the universal set, which are also present in the set A. So besides that, the other elements will make the set complement of the set A. So that is going to be 5 6 7 8 and 9. So it's quite simple, not complicated, not difficult at all. All right, let's move to the other one. Then the other one, second one, says complement of B, that's the set B. So same way, that's going to be universal set minus the set B. So all the elements which are not in set A, 2 4 6 8, 2 4 6 8. So we are going to be left with 1 3 5 7 9. So complement just means that the elements which are not in the given set. Question number 3. The third one they are asking is A union C, its complement. So for that, let's first find out A union C. Let's do it systematically. So A and C, if we combine, so that will be 1 2 3 4 5 6. So what will be A union C complement? What will be A union C complement? That is all the elements leaving this element. So 1 2 3 4 5 6. So the elements will be 7 8 and 9. All right, let's go to the fourth one. The fourth one is also similar, that is A union B complement. So let's first find out A union B. So what will be A union B? 1 2 3 4. 1 2 3 4, 1 2 3 4, 2 4 already there, 6 and 8. So A union B complement will be 1 2 3 4 6 8. 1 2 3 4 6 8, 5 7 9. 5 7 9. All right. Okay, number 5. Number 5 will ask for A complement of its complement. The complement of A complement. So as you can see here, this is the law of double complementation. That is, the complement of A complement will be A itself. Let's prove it with this example. That is, what is going to be A complement? Let's first go for A complement, okay? A complement we have already got here, that is 5 6 7 8 9. Then what will be the complement of A complement? The complement of A complement, that is all the elements leaving aside this element, 5 6 7 8 9. So that will be 1 2 3 4. Isn't it the set A? So that's somehow like proved also, this law of double complementation. All right. Okay. What's the last one? The last one is, I'll just do here, b minus c complement. So let's first find out b minus c. Always do systematically. Okay. So b minus c. So 2, 4, 6. Okay. If you wish me, I'll just write, no problem. Minus 3, 4, 5, 6. So 4 can be out, 6 can be out. So I am going to be left with 2, 8. So b minus c complement will be leaving aside 2, 8, all the other elements, 1, 3, 4, 5, 6, 7, 9. 1, 3, 4, 5, 6, 7, 9. 1, 3, 4, 5, 6, 7, 9. Okay. All right. Simple, isn't it? Chalo, let's move to the next question. Number 2. Same again. The set, universal set is given. Find the complements of the following sets. So first one, let's do it directly. A complement, A, B, C. So leaving aside that, the other elements, D, E, F, G, H. I hope all of you are noting it down. Please write down along with me. B complement, D, E, F, G. D, E, F, G. So that will be A, B, C. A, B, C, H. Next is C complement, A, C, E, G. Leaving aside that, A, C, E, G. So that will be B, D, F, H. Alright. That last one, D complement, F, G, H, A. F, G, H, F, G, H, A. So that will be A, B, not A, B, C, D, E. B, C, D, E. Okay. All right. Next one, that is taking the set of natural numbers as a universal set. So our universal set is X such that X is the set of natural numbers. Or you can also write like X such that X belongs to natural numbers. So this is our universal set. So natural number means, I'll just write here, that is like 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So the first one is, let this be our set A. Okay. So write down the complements of the following set. So A complement actually will be universal set minus the set A. What is a set A? Set A is an even natural number. So if we just leave all the even natural numbers, we are going to be definitely left with the odd natural numbers. That is X such that X is an odd natural number. Simple as that, odd natural number. All right. Okay, moving on. Done. You can pause the video there and you can note down. All right. All right. Let's move on to the next question. Number 2. Almost same here. Let this be our set B. So here we have X as the odd natural number. So just like just the reverse of that previous question. So U minus B. We need to find B complement. So that's going to be simply X such that X is an even natural number. This one. Let this be our set C. So C complement will be universal set minus the set C. So what is the set C? It is a positive multiple of 3. Positive multiples of 3. So if we remove all the positive multiples of 3, definitely we are going to be left with the not the multiples of 3. So it's very easy to write down. So that is like X such that, of course, X belongs to natural numbers because we are dealing with natural numbers only here. And X is not a multiple of 3. So this is what it is, this is what it is not. Something like that, no? Okay. Next one. Let this be our set D. So D complement will be universal set minus the set D. What is our set D? Prime numbers is a prime number. So the other one will be what? All the sets which are not prime numbers. So we can also write like X such that X is a natural number and not a prime number. Or in other words, we can also write x such that x belongs to natural numbers and x is a positive composite number, and x is a positive composite number. Alright, and x is a positive composite number. Of course, we should not be forgetting that 1 is also there. Okay, so x is a positive composite number and x equal to 1. So that should not be forgotten, because 1 is neither a positive nor a composite number. So prime number, neither a composite nor a prime number. But here we are supposed to write on the set which is not a prime number. So composite numbers and x equal to 1, because 1 also has to be included. Alright, let this be our set E. So E complement will be universal set minus set E. What is our set E? Natural number divisible by 3 and 5. Natural number divisible by 3 and 5. So that will be something like x such that, see, what is a number that is divisible by 3 and 5? Can you think of some examples? Numbers which are divisible by 3 and 5. What is the smallest natural number? 15. Divisible by 3 as well as 5. Then 30, I guess, right? 30. Then 45. So that means automatically a natural number which is divisible by 3 and 5 is a number that is divisible by 15 automatically. So we can write it in that way also. That is x such that x is a positive, or let's say, forget about positive, we're talking of natural only, na? X is a natural number which is not divisible by 3 or not divisible by 5. Or in other words, we can also write x such that x belongs to natural numbers, okay, and x is not divisible by 15. Actually, this one is more appropriate, not divisible by 15, because a number that is divisible by 3 and 5, as I said, it starts from 15, 30, 45, natural numbers. So automatically it's a multiple of 15. Okay. All right. Another one. X is a perfect square. So that's going to be very simple. So what was our last set? E. So let this be our set F. F complement universal set minus F. So that's simply going to be x such that x is not a perfect square. G, this is a perfect cube. Same way we can just write that is G complement will be universal set minus G, that is x such that x is not a perfect cube. And of course x belongs to natural numbers. X belongs to natural numbers. Let's not forget to write on that also. No? Alright, this one H. So what is this set actually? X plus 5 is equal to 8. That is x is equal to 8 minus 5. That is 3. That is actually H can be written as again x such that x belongs to natural numbers and x is equal to 3. So like that will be just 3 itself. Now the set 3. So H complement will be universal set minus the set H. So that can be just written as x such that x belongs to natural numbers and x of course is not equal to 3. A, B, C, D, F, G, H, I. So this HI can be, the set I can be written as, let's calculate, 9 minus 5, 4, x equal to 2. So I is actually what? Only 2, because 2x plus 5 equal to 9, so x will be 2. So that means I complement will be universal set minus I, that is simply going to be again x, almost similar, belongs to natural numbers, and x is not equal to 2. Okay, all right. This one, let's say the set J. So what is this set? X belongs to, of course, natural numbers. Definitely it's already given. Greater than or equal to 7. So that's going to be greater than or equal to 7, starting from 7, 8, 9, 10, and so on. So J complement will be universal set minus the set J. So we are dealing with natural numbers only. So 1, 2, 3, 4, 5, and 6. Alright, what about the set K? Natural numbers. 2x plus 1 is greater than 10. So 2x plus 1, that is greater than 10. So of course, if you wish to calculate, we can calculate, that is 2x is 10 minus 1, that is 2x is 9, x is greater than 9 by 2, 4.5. Greater than 4.5, but remember x belongs to natural numbers. So greater than 4.5 natural numbers. So it will be 5, 6, 7, 8, 9, and so on. So K complement will be universal set minus the set K. That's going to be 1, 2, 3, 4. Okay. Chalo. Done? Alright, next. This is the De Morgan's law. So sometimes in the exams they might just say, no, without giving this, verify the De Morgan's law. So you have to know the De Morgan's law also. And it's very simple. That is, look here, it's simply A union B complement will be equal to A complement. Union becomes intersection once you take it outside the bracket. Something like that. In that way you can remember easily. And A intersection B complement will be A complement. Once you take it out, union. No reverse. Now for that, let's first find out A union B. All the sets that we require, let's first find out, do very systematically, then you will have no problems at all. So A union B, let's combine the set A union B. A, B, so that's 2, 3, 4, 5, 6, 7, 8. A complement. 2, 4, 6, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. B complement 2, 3, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. B complement. So now A union B complement. What will be A union B complement? 2, 3, 5, 6, 7, 8. 2, 3, 5, 6, 7, 8. So 1, 9. And A complement intersection B complement. A complement intersection B complement 1, 9, 1, 9, 1, 9. So therefore it's proved A union B complement is A complement intersection B complement. Do systematically, do not lose any marks from here. Okay. Alright, let's move on to the next part. Second one. A intersection B. So let's first find out A intersection B. So A intersection B, what were the sets? A and B. So A intersection B will have 2, 4, 6, 8. So we have only 2, isn't it? A intersection B, we have only 2. Alright. So what will be, and A complement and B complement, we've already found that in the previous question, so we'll just make use of that question. So sorry, A intersection B complement will be 1, 3, 5, sorry, 1, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. And A complement union B complement. Let's combine A complement. You already have it. You can check your notebook. That is 1, 3, 4, 5, 6, 7, 8, 9. Therefore, hence proved. All right, now let us move on to question number 5. That's about Venn diagrams. Let me take out a pencil also. All right, draw appropriate Venn diagrams for each of the following. So let me just write this as the set A, set B. First one, A union B complement. So let us first have A union B. Okay, that'll be easier for us. So A union B would be, I'll be combining A union B. So this is going to be my set A union B. So it's very simple. Complement means just the reverse of it, isn't it? So all these elements. All right, and this is A union B complement. Okay, my dear students, here now A complement intersection B complement. A intersection complement B. A complement intersection B complement. Now for this, I'll just do it here. That is, what is A complement? Let's do it together. I have just drawn two diagrams, but what is A complement? A complement will be everything that is except A. Right, look carefully. Now, this is A complement. Then what is B complement again? B complement will be everything that is leaving B. This is A complement. Now B complement, if you go for it, everything that is except B. B complement. So what will be A complement intersection B complement? That is a common point. That is like A complement intersection B complement. So if you look carefully, A complement was all the elements leaving aside this circle, remaining all. B complement was all the elements leaving aside this. So what is its common region? Common region is this one, isn't it? Right, once again, A complement means just leaving aside this one. Now, could you understand? Let me just use something like this. Okay, it's too big. Anyway, okay, I'll just use this one. A complement is like this, isn't it? No, just leaving aside this. B complement is this. Now, if you look at the common region, intersection means common. So common, both of them will share this region. Intersection. So the region which both of them will share is this region. I hope you're not confused, my dear children. Just think about it carefully. We have intersection, that is, we're talking about the common region, no? Between A complement and B complement. So A complement is all this, B complement is all this. So definitely this region doesn't belong to B, this region doesn't belong to A. So when you talk of B complement, it's only this A complement, this part, but these two parts are not included in both, isn't it? Now when we go for intersection, it's about both the regions which are included as well as in A complement as well as B complement. So this is the only region that is included which both A complement and B complement shares. Okay. Diagrams, we need logical reasoning also, no, for that. All right, A intersection B. What is A intersection B? A intersection B, okay, this is much easier, no confusion here. A intersection B is this. And so very simple. What is A intersection B complement? Quite simple. Oh yeah, the remaining. Complement means leaving that part, remaining all. You can just draw lines also with scale. Okay, I'm just doing it in a hurry. But if you have all the time in the exams, you can shade also, no problem, like this. All right. Next, almost similar like the other one. Like this time, what is A complement? I'll draw 3 diagrams here. That'll be better. So what is A complement? A complement, as I was just saying, everything that is not of A. So that previous question, number 3, if you can maybe do with 3 diagrams, I think that will be better for you. Okay. And B complement, if we take this as a set A and B. B complement everything except B. Please go through the videos of the Venn diagrams which I've prepared for you also, the concept video. That way it will be clear. These topics are also discussed slightly. Some formulas how we derive from the Venn diagrams are also discussed. So go through it properly. So this time it's not about intersection. This time it is about combination. Combining. So if we combine these 2 figures, this also comes. This also comes. In that intersection, these 2 did not come. And this one of course doesn't share. So everything except union, this one. Union means combination, combining. Except this region. All right. Okay, I think that's clear. If you have any doubts, please do let me know. Okay. All right. Of course, it depends on your practice. The more you practice, the better. Okay. Number 6. U is the universal set of all triangles. That is, X is a triangle. Let's say in a plane. Let's just say. If A is like what? Set of triangle, as it is given in the question, set of triangle, and has at least one angle different from 60 degree. At least one angle, at least one. The condition is that set A is a set which is comprised of triangles where at least one of that angle is different from 60 degree. At least, that means all the 3 can be different from 60, like 50, 70, no, let's say 50, 80, 50, something like this also possible, 100, 180, yeah, isn't it? So what they are asking is what they are telling you is that the set A is a triangle which has at least means we can have more also, but the condition is a minimum कम से कम एक तो होना चाहिए 60 से अलग. It has to be different from 60, but we can have all the 3 also different from 60, 2 different from 60, just 1 different from 60, right? That's what they mean. Question is, what is A complement? So A complement can be like, if we think carefully, A complement, the only complement of A can be like all are 60 degree, isn't it? That's the only complement for A, because A says at least one should be different from 60, at least. So it can be 2 also, can be all the 3 also, all the 3 can be different from 60, or at least one should be different from 60. So we can counter attack, right? We can counter that by just saying that, all right, all are 60. So all are 60 means it completely disapproves this part, that is leaving aside the set A. So A complement will be all the angles are 60 degrees. So that is like X, such that X is a triangle and has all angles equal to 60 degree. So that is what? That is simply set of all equilateral triangles. Simple as that. No, we need to really use our concept imagination also. Okay. All right. Next, fill in the blanks to make each of the following a true statement. A union A complement. A union A complement. So we just carefully look at the set Venn diagram. A kya kar diya? I just need one set A. Set A. This is set A. Its complement will be this one. If we consider this as a universal set, this is set A, and leaving aside set A makes the complement of set A. Now, if we combine these two, what do we get? Definitely, we are going to get the complete set, universal set. Second one, empty set intersection A. Now, what is empty set? Empty set is universal set. Universal set intersection A. Empty set complement, not empty set, sorry. Complement of empty set is reverse, universal set. All right. So universal set and the set A. So if we just again here also, like this is a universal set and the set A. Intersection means common element. So common element between universal set and the set A is the set A itself, because both of them will have to share the same elements. So the set A can share elements only with it about itself only. So that's going to be set A. Third one, A intersection A complement. Just now only we have seen. What is A? This is the set A. What is A complement? This is the complement of the set A. This is intersection. So what do they have in common? They are not supposed to have anything in common. So intersection. So that's going to be a null set. All right. Is that clear? A intersection A complement. So A, this is A in A complement. Common, nothing. Fourth one. Universal set complement intersection set A. That is empty set intersection set A. Of course, that's going to be set A only. Empty set and set A. What are the common elements? Oh, intersection, sorry. Not union. So with an empty set and a set A, any set, what can they have in common? Definitely empty set will not have anything common with any set. So, sorry, the answer will be a null set, an empty set. Alright, is that clear? Okay, so that's it. If there is any confusion regarding anything, please do let me know. Alright, just go through the video, write down the notes properly, and any confusions, let me know in the comment section below. I will clarify that. Okay, alright then, study well, take care, bye bye.